Hello everyone, and welcome back to my series on Solidworks tutorials. In a previous video, I showed you how to use the hole wizard and stud wizard to create a threaded part. Threads in big air quotes there, because those features only show you a dashed line where the minor diameter of the threads are, and it will give you a call out for the thread on the print, but it won't actually show you the threads. Another downside to them is not every thread is available. If it's non-standard in any way, it's not going to be part of the hole wizard and stud wizard. So I'm going to show you how to get cosmetic threads and ones that don't exist in the hole wizard and stud wizard. So what I have here is a 25 millimeter diameter. It's 50 millimeters long, but that doesn't matter because what I'll be cutting threads on is this section right up here. Just a quick overview of how I made this. This entire piece is this boss extrude up here, and then I have a cut revolve that actually forms this bit right in here, and that's stuff I've covered in other videos. If you want to see it, go take a look at the rest of the playlist. To get these threads, we're going to have to do several things, and all of these have been covered in another video, but I'm going to go through them again here. So I've gone to my Features tab, which is in the top left corner of the screen. The very first thing I'm going to do is come to Reference Geometry, and I'm going to put a plane that is offset from this face. And it doesn't have to be far. I'm going to have it offset by maybe 2 millimeters. That's fully defined. I don't need to do anything else. And as you can see, there's a plane floating above that face. The next thing I'm going to do is put a sketch on that plane. So I've gone back to my Sketch tab, hit Sketch, and I'm going to select that plane. And I'm going to draw a circle that is equal to my minor diameter. And I'll put it right there, and then use Smart Dimension to get it in place. The thread that I'm cutting is 25 millimeter by 1 millimeter pitch. So I'm going to make this 24 millimeter circle. There we are. That's all I need to do here. I'm going to exit that sketch. I'm going to hit this zoom to fit button so that we can see that a little easier. So we have a circle drawn on that plane, and now we go back to our Features tab, and right next to Reference Geometry is this Curves button. If I hit this drop down, there's quite a few options, and the one I'm interested in is Helix and Spiral. So I'm going to click that. It's going to open a dialog box, just like pretty much everything. And I'm going to click this planar face, or I can just hit this circle on the plane. And that's what I really want to do. So I'm going to click that, and it opens up the rest of the dialog box here. So here we have a few different things. You have a drop down that lets you choose from a few different options, pitch and revolution. So that's going to be the distance that a full rotation makes, as well as how many revolutions you want it to make. Height and revolution, same deal, height and pitch, and not really sure what spiral is actually. So I'm going to keep this at pitch and revolution. I'm going to keep it at constant pitch as well, which is what you would want for a screw. Variable pitch would be something more like a spring. You can reverse the direction. In this case, you can see this arrow coming off the face, so I do want to click that, and now it'll go down the face of the tool. I have my pitch, which I'm going to change to 1 millimeter pitch. The next thing is the number of revolutions. Now I know I put my plane 2 millimeters above my surface, and I did that because otherwise when I start cutting this thread, cutting again in air quotes, it's going to, if I had it starting on that face, even if I drew a circle on that face, it would have a very abrupt start right at the very first thread, and it wouldn't look realistic. So I put the plane above the face so that basically it cuts air for a little bit and then it cuts into the material. Now I know that my plane is 2 millimeters above my face there, and I believe I made that 6 millimeters long. I'm going to put 7 millimeters, or 7 revolutions, pardon me. There we go, and I think that'll do it. That gets down into the thread relief there. The danger, I could do 8 millimeters, but then the danger is that I would have a partial thread in this shoulder, and I don't want that. The next thing is the start angle, and that's not terribly important in this case. It can start anywhere on this part. But for instance, if you were going to make multi-start threads, you could make reference geometry with different planes and have each helix start at a different angle. So for instance, 0, 120, and 240, and you would get 3 starts. Next we have clockwise and counterclockwise. So that is just the direction that it is winding around. So right now I've got it at clockwise, and you can see that would be a right-handed thread, so righty-tighty, lefty-loosey. If I wanted a left-handed thread, I could hit counterclockwise and it would go the other direction. The last option is taper helix, and if I click that, it lets you type in a number of degrees. So let's say I just typed in 10, and you can see now our helix is moving around at an angle. I have an angle to the center line of the part, although it may actually be an included angle between them. You can use that to cut pipe threads, for instance, or maybe a conical spring. You can do a lot of stuff with this. I don't want to taper my helix though, so I'm going to turn that off. And I believe I've got everything just the way I want it. So I'm going to click the green check mark. Now that I have a helix drawn around my part, all I need to do is draw a thread form. Imagine you're at a lathe and you have a threading tool. That's basically what you're drawing here. First thing I'm going to do though, I don't need to see this plane anymore. So I'm going to come up to this eye icon right here. This is my hide and show items. I'm going to hit the drop down and I'm going to get rid of that plane. I don't need to see it. Eventually I'll also get rid of that helix because otherwise it will stay there. Alright, let's go ahead and draw our sketch. So we're going to come to the sketch tab up here. I'm going to start a sketch. I'm going to bring down my feature manager design tree so that I can choose which plane I want to be on. And I believe I want to be on the right plane. That seems like it's right, because I believe my helix starts right up there. I'm going to zoom in a little bit. I'm going to grab my line tool and I'm just going to start drawing. And all I need to do is draw a rough triangle here with a flattened tip, because the thread standard does call for a little bit of a flat at the tip of the tool. Now I need to dimension it. So the first thing I'm going to do is make sure that this is an equilateral triangle by defining all of the angles at 60 degrees. I only need to say that 2 of them are 60 degrees. Next I'm going to zoom in and I'm going to define the width of this flat. And I've already looked this up, so I know exactly how wide it should be. It should be 0.25 millimeters. And then I need to just give it a dimension this way. 3 millimeters seems a little excessive. I'll just do 2 millimeters. So there we are. I still have a blue sketch, and that's because I don't know where the entire triangle is. So what I'm going to do is dimension from, I wonder if I cannot snap to the point at the end of that helix, but I can snap to this line, and I'm going to go to the midpoint of that circle, or the midpoint of that line right there. There we are. And I'm going to make that 2 millimeters. That should put the midpoint of the line right level with the top of the helix. My computer is running quite slow right now because the helix, it's constantly trying to redraw it, and that is labor intensive on the graphics processor and not exactly something that my computer is up to date with. So I'm going to come down to my my origin point down here. I'm going to zoom back in, and I'm going to click that line again. And I know that I want it at 24 millimeters, so this is 12 millimeters from the center. And now my sketch is right at the edge of that spiral, and it's fully defined. At this point, we're ready to do a sweep cut, which I showed in a previous video again. So let me go to Features. I can't choose Swept Cut just yet because I'm still in that sketch. So let me exit my sketch. Now I have my sketch and I have my helix. I can go up to Features. I can do Swept Cut. It automatically chooses the profile as the sketch that I just had, and for the line I can choose the helix. So helix spiral 1. Now when I click this green check mark, it's going to sweep cut that profile all the way around, and you will see that it cuts a thread. I got this rebuild warning, and let's turn this into a teachable moment because I know exactly what caused this. It is the shape of the thread. The fact that this is 2 millimeters long, and basically the point of this part of the triangle is going to intersect with the point of this part of the triangle when it sweeps back around. So easy peasy, we'll just come back in and we'll edit this sketch. And let's see, instead of 2 millimeters, let's see if we can make this 0.6 millimeters. And let's see if it'll do it. If it won't, then we'll just sort of clip off these edges a little bit. Let's exit the sketch. We'll go back to Features, Swept Cut. We'll choose our sketch, and then we'll choose our helix. And it shows you a preview, and you can see it just clears. So the bits are not going to intersect with each other, and that's all that matters. So I can click my green check mark, and now I have a nice thread cut all the way around my part. And I'm going to just roll around. Now, one part that I'm interested in seeing is the very end of it, and yes, it looks like it went into the thread relief and disappeared, which is exactly what I wanted. If I had ended the helix too early, you can see the helix actually ends right here. And if it had ended, say, somewhere within this geometry, I would end up with a big flat spot where the thread just ended. And that's, again, not very realistic. In the real world, you cut this on the lathe and the thread just sort of disappears into the thread relief, and that's exactly what we want here. Alright, I'm going to come back up here and I'm going to turn off curves. That's going to get rid of my helix. So as you can see at the very top of the thread, this is where it comes in, and this is a very realistic looking part because your chamfer here at the beginning actually removes a little bit more material than the minor diameter of the thread, and then the same thing happens at the very end, just like I showed a bit ago. Now we have a really nice looking cosmetic thread, certainly nicer than what you get with a hole wizard and a stud wizard, plus you can get any thread regardless of its thread pitch and major diameter. So why isn't this standard? Well, the answer is processing power. You can see when I mouse over every single one of these features, they start lighting up like a Christmas tree. And that's because it has to render every single angle on this, and it does it whenever you're moving the model like this. So basically it makes the program run smoother. Let's take a look at another example that you can do with this. This is a boss extrude, basically the exact same sort of thing that I just did, except I'm going to thread this entire part. And let's go ahead and get up to that point. I'm in features, I'm in reference geometry, I'll put a plane. I am actually in inch-pound seconds here, so in this case, tell you what, I'm going to go 1/4 of an inch above my face. This is fully defined. I'm going to make a sketch on that plane. Let me draw my circle right here, and this is going to be my minor diameter. It doesn't have to be your minor diameter. You could have it be your major diameter if you wanted to, and then have a point defined within your sketch that you can snap to your helix. I find it just a lot easier to make it the minor diameter. That's just me though. I happen to know the measurements I'm shooting for here because this is a thread we recently had to make it work. A double start 3/4 8 Acme left-handed. So this is really interesting to show. Let me do my curve, my helix and spiral. Since this is a double start thread, I actually need to put in double the pitch because I'm going to have two different threads intertwined with each other that start 180 degrees apart. So in this case, if it's 8 threads per inch, I need my pitch to actually be 1/4 of an inch. And let me see, number of revolutions. This isn't terribly important. I'll say 10, so it actually goes off of the part the other way. And I want this to be a left-handed thread, so I'm going to say counterclockwise, and now you can see it's going around this way, and so that would be a lefty-tighty, righty-loosey thread. That should do it for the helix. And let me see which plane is going to go through the beginning there, at the right plane. So that's where I'm going to put my sketch. Sketch. I'll go to my tree again, choose my right plane, and then I'm going to draw my shape here. This is an Acme thread, so it's going to have a pretty good size flat on the end. It has 29 degrees for the angle. In metric, these are called trapezoid threads, and it's a 30-degree angle. Let's see, I'm good there. Let me start dimensioning it. I know the flat on the end needs to be 46 thousandths of an inch wide for 8 threads per inch. I know that the angle here has to be 29 degrees. This is going to throw in some wonky angle. It's only going to move one of them. So then I know my angle here, it's going to be 90 minus, let me see if I can get to this, 72 right there. 90 minus 14.5. And I can actually type that math in, 90 minus 14.5, and then it snaps all that together. So now I have an even 29 degrees off of the center line. Alright, from the origin to there will be the same size as my circle, so that's going to be 0.590 divided by 2. There we go. And then from this face to the center point of this line is going to be 1/4 of an inch, 0.25. The rest of this doesn't matter a ton. I'm going to just make this 100 thousandths. I think that should do it. So we have that fully defined. And now I can exit my sketch. And actually, I do not want to exit my sketch. I want to edit my sketch. I'm going to pan up. I'm doing this by hitting the Control key and then clicking my center scroll wheel. I am going to mirror this. I'm going to put a center line right here going up. Doesn't need to be defined. I'm going to mirror the entities, and I can just click the face of this sketch and it will choose every line. And then for the mirror about line, I can just choose that center line that I just drew. Now it puts it over there. Since I want a double start thread, I can just mirror this and have the correct pitch, and when I do my sweep, everything will end up perfect. So let's show that. Yeah, I need to exit the sketch. I'm going to go to Swept Cut. I'm going to go to my tree and choose that profile of sketch 3 right there. And then I'm going to choose my helix. And you see your profile there. And eventually it's going to render. Just so we can see that better, I'm going to hide the plane, I'm going to hide the curve, and now we can see a really nice looking double start left-handed 3/4/8 thread. Of course, you can do all of this with internal threads as well. This is actually the mating part to that double start 3/4 inch left-handed Acme, and I did the exact same tricks. I put a plane above my geometry, I drew my helix, I have my sketch of the thread form, and I mirrored it on the other side so I can get the double start. And all I have to do is a swept cut here. So I'll click that, I'll choose the profile. Might have to go to the tree for that. Yeah, choose that profile, choose that helix, and now it gives me my my preview. And you can see this one ends in the middle of the part, but it's actually past the section that would be threaded. There was a relief on the back side of this. So let me hit my green check mark. And now you can see our 3/4/8 left-handed double start Acme on the inside. And you could see it a lot better if I hid the plane and hid the curve. And if I click out there, the sketch disappears. So there's the beginning of one thread, the beginning of the other, and it goes all the way through to the end, just like that. So far, I've done all of my examples as a swept cut, meaning that I drew my cutting tool and then swept it around to remove the material, just like I would if I was actually cutting this on a lathe. Now conceivably, you could also do this as a swept boss base. That's generally used for things like springs, but let me show you. Here I've extruded out a cylinder that is the minor diameter of my thread. I'm going to come up here to curves. I'm going to choose helix and spiral just like I did before. This time I'm not going to create a plane and draw it from that. So I'm going to choose this top face. This opens up a sketch. So right now the easiest thing to do, I could draw a circle and just go right out to there, or I could just hit convert entities and choose the face. And when I click that, it will draw a circle for me right there at the edge. Now I can go back into features and hit my helix and spiral again, and I can start putting in all of my my parameters. So in this case, I'm making an M6x1 thread, so my pitch is going to be 1 millimeter. And let's see where that ends up here. Yeah, that's fine. That should be perfect. And I do need to turn this to clockwise if I want a right-handed thread. Okay, easy peasy. Now we have to draw our geometry. So let's start with that. We'll open up our sketch, go to our tree, and this is going to be the right plane, I believe. Yep, that starts right up there at the top of the helix. So here I'm going to be drawing my sketch out this way. how do I know what to draw? That's an excellent question. The thread form for Unified National and for isometric are all based on equilateral triangles. So that makes things pretty simple. And they're all spelled out. And actually the two thread forms are incredibly similar. There's just some very minor differences. But for all intents and purposes, they are exactly the same. So I'm just going to start at the corner of the part here. I'm going to draw roughly a 30-degree angle there. Threads do have a bit of a flat on the tip, so I'm going to put that in. And again, I'll do roughly a 30-degree angle back the other way, and then I'll close up my feature. So now I can dimension all of this. The thread specifications are incredibly well spelled out, so you can Google isometric thread form or Unified National thread form or any of the other thread forms and get exactly what you're looking for. So let's go ahead and get this defined. I'm going to set this at 60 degrees. There we go. I know the flat at the tip, according to the standard, is supposed to be 1/8 of the pitch. Since the pitch is 1 millimeter, this is going to be 0.125 millimeters. I'm going to real quickly draw a center line snapped from the midpoint here and perpendicular over here, and that way I can define the angle between that center line and here. So let me get back to Smart Dimension. And yeah, you can see it's a little bit off. There we go. And now since my angles are defined and my flat is defined, this dimension here is the only thing left to define, and it should actually be set according to the triangle. So I shouldn't actually have to type anything in there. So I just hit enter, and now I've got my fully defined sketch. And we'll do exactly the same thing that we did before. We'll exit our sketch so we can do our sweep. We'll go to Features. We'll do our swept boss base. It already chose that sketch for us. And then we will choose the helix. And it shows you the preview just like before. And already you can kind of see some of the problems that are happening with this. And there are a few others that are kind of my fault. But the big thing, let me go ahead and hide the helix. The big thing is that the thread starts at the very beginning of the helix. So this is not a realistic looking part. You have this just flat, abrupt beginning, and at the bottom it actually goes past the end of the piece. So you have this flat, abrupt end that goes actually past the end of the material. Now you could do a few extra steps and a few extra cuts and add some chamfers and things like that to make it look more realistic. Or you could start off the part like I did originally and then trim things. You could do a lot, but that adds a ton of different things that you need to do in order to make this look realistic. You can also see the width of the flat at the bottom of the thread is entirely too wide to be realistic, and that's just me being lazy. It's got nothing to do with the sweep. What I did was I drew the cylinder to be 5 millimeters, which is major diameter minus pitch. That would give you the tap drill size for tapping this hole, but it's not the actual minor diameter. That would be smaller. So if I had taken the time to actually look up what I was supposed to put in there instead, then it would look more realistic. Now conceivably, if you were a masochist, you could draw the entire thread form all the way down the part and then just do one revolution of the helix at the correct pitch, and it would sweep the entire thing around. You would still end up with this abrupt beginning and end. But beyond that, you would have to draw and define the entire shape and that is what is colloquially known as a massive pain in the butt. So don't do that. That just about does it for this video. Hopefully you found it helpful, and if you did, please consider hitting that like and subscribe button down below. And if you have any questions about this or any other SolidWorks or machining topic, leave those down in the comments section. Thanks for watching. I'll see you next time. I'm going to make that 90 thousandths there. Oh, I made it 90 inches. That's undo.